Hello, night travelers. Welcome back to the Night Observer, a quiet place where weary souls come seeking rest, comfort, and gentle sleep, guided by drifting thoughts about the vast and mysterious universe. Let me ask you something, in this calm hour of the night. What comes to your mind when you think of black holes? Do you imagine a terrifying, greedy monster, an endless abyss that devours everything in its path? Perhaps something like Apep in ancient Egyptian mythology, the serpent of chaos forever attempting to consume order itself, held at bay only by Ra, the sun god. In the imagination of many, black holes take the role of a cruel villain, lurking in the darkness of space. Yet the truth is far more subtle and far more beautiful than we often imagine. Come, night travelers, sit with me for a moment. I have lit a small fire here for you. Let its gentle warmth soothe your spirit and quiet your thoughts. Allow your mind to loosen its grip on the day and listen as we begin a story about one of the universe's greatest mysteries, the black hole. Together, we will trace its journey from a quiet idea born in human thought to a profound reality written into the fabric of the cosmos. You will see how entire galaxies move to its rhythm, how stars and light themselves respond to its silent presence. And perhaps you will be surprised to learn that what we once feared as pure destruction is, in fact, a force that has helped shape and sustain the universe for billions of years. Even a black hole, often imagined as a monster, has its own graceful motion, its own cosmic dance. Its power is not merely violent, but strangely elegant, unfolding like a tragic and beautiful song written across time and space. Now, let your shoulders soften. Allow your body to settle comfortably where you are. Feel the weight of the day gently lift away, leaving your mind light and unburdened. Turn your thoughts toward the deepest reaches of the universe, into regions so dark that even light cannot escape. Let the fire beside you cast its quiet glow, guiding you gently toward the cold, silent heart of the black hole. This chapter speaks of the beginning of darkness, of how the brightest stars, at the end of their long lives, surrender themselves to become the most powerful objects the universe has ever known. Listen closely to the whispers of space. Let this story carry you gently, slowly, into a peaceful and well-deserved sleep. The gateway to the realm of nothingness, the silent heart of the Milky Way. Some 26,000 light-years from Earth, concealed behind vast curtains of cosmic dust and dense clouds of gas, lies one of the most restless regions in our galaxy, the very center of the Milky Way. Here, streams of gas surge and collide, radiation flares with startling intensity, and stars trace chaotic paths through space. Yet at the heart of all this turbulence rests something profoundly still, an invisible giant known as Sagittarius, a star, the supermassive black hole anchoring our galaxy. Sagittarius A holds a mass 4 million times greater than that of the Sun, compressed into a region smaller than our solar system. It is density beyond ordinary imagination, its gravity quietly commanding the motion of billions of stars around it. And yet, despite its overwhelming influence, it remains remarkably elusive, its presence inferred more through its effects than through direct observation. In March of 2019, scientists turned the XMM Newton Space Telescope toward this hidden heart and uncovered something extraordinary. Two immense plumes of superheated gas, glowing fiercely in X-rays, were seen rising above and below the black hole. These towering structures stretch nearly 500 light-years in each direction, like vast cosmic chimneys venting ancient energy into space. One might imagine them as the lingering breath of a long-past outburst, matter struggling briefly against gravity before surrendering once more. These X-ray pillars appear to connect directly to the Milky Way's largest known formations, the Fermi bubbles, each spanning some 25,000 light-years. Together, they whisper of a distant era when this silent giant was far more active, feeding intensely and reshaping its surroundings. The fatal end of stars. To truly understand black holes, we must begin much earlier, with the final moments of massive stars. Every star lives by a delicate balance. Deep in its core, lighter elements such as hydrogen fuse into heavier ones, releasing energy that pushes outward against gravity's relentless pull. In the most massive stars, this process continues far beyond what smaller stars can achieve, forging carbon, silicon, and ultimately iron. Iron, however, marks a quiet turning point. Unlike earlier fusion reactions, it releases no energy. When an iron core grows to about 1.5 times the mass of the Sun, a boundary known as the Chandrasekhar limit, the outward pressure can no longer resist gravity. The balance fails. The core collapses inward with astonishing speed. In many cases, this collapse triggers a cataclysmic rebound. Matter slams into the core, generating a shock wave powerful enough to tear the star apart in a brilliant supernova, briefly outshining entire galaxies. What remains is a neutron star, an object so dense that imagining it strains the mind. It is as though an entire mountain were compressed into something no larger than a marble. Yet even this is not always the end. If the remaining core exceeds a critical threshold, the Tolman-Oppenheimer-Volkoff limit, then not even the pressure between neutrons can halt the collapse. Gravity wins completely. Atoms are crushed beyond recognition, their structure erased. Space and time themselves are forced to bend. In that moment, a black hole is born. Matter does not merely disappear, it leaves behind something far more profound, an extreme curvature of space-time, a silent imprint where gravity reigns without limit. What was once a brilliant star becomes a gateway to nothingness, a presence defined not by what it shows us, but by what it forever hides. And so, in the quiet heart of our galaxy, the story continues, unseen, unhurried, and deeply eternal. Anatomy of a cosmic ghost. A black hole is far more than simply matter crushed to an extreme. It is a region of space-time where reality itself takes on unfamiliar and unsettling properties that modern science is still carefully learning to describe. The event horizon. The defining feature of a black hole is its event horizon. This invisible boundary marks the point of no return. Once anything crosses it, matter, energy, even light, it can never again communicate with the outside universe. From that moment on, all events within are sealed away, forever hidden from view. In the language of relativity, a black hole may be thought of as a tear in the fabric of space-time, so deep and so steep that escape becomes impossible. To a distant observer watching from afar, time itself appears to slow as an object approaches this boundary. This effect, known as gravitational time dilation, causes the falling object to seem frozen in place, hovering at the edge of the horizon. Its image gradually dims, reddens, and fades until it vanishes completely, an illusion that unfolds in less than a second. Yet for the object itself, the experience is strangely uneventful. As it crosses the event horizon, nothing locally announces the crossing. Time continues to flow normally, at least for a while, and the boundary passes without ceremony. The singularity. At the very center of a black hole, according to the equations of general relativity, lies the singularity. Here, space-time curves infinitely inward, and the entire mass of the black hole is compressed into a point of zero volume. Density becomes infinite, and the familiar laws of physics cease to function. This extreme state is often described in terms of Planck density, a condition so severe that even imagining it strains the limits of thought. If all the stars in all the galaxies of the universe were compressed into a space smaller than an atom, the result would still only hint at the intensity found here. Temperatures rise to levels trillions of times greater than those at the Sun's core. And yet, many physicists suspect that this singularity may not truly exist as described. Instead, it may signal the breakdown of our current theories. a sign that general relativity must one day be joined with a deeper, more complete theory of quantum gravity, the dance of spaghettification and the spacefall. As one approaches a black hole, gravity ceases to be a gentle pull. It becomes something far more dramatic, a sculptor that stretches, distorts, and ultimately destroys. Spaghettification. If an astronaut or an unfortunate star wanders too close, it will experience a process scientists grimly nickname spaghettification. Imagine falling feet first toward the black hole. Gravity grips your feet far more strongly than your head. This difference, known as tidal force, stretches the body relentlessly, pulling it into a long, thin strand. Molecules separate, atoms unravel, and matter is drawn out into a luminous thread before disappearing entirely. Astronomers have witnessed this fate befall distant stars, capturing brief, brilliant flashes of light as they are torn apart and swallowed forever. The space waterfall. To help visualize this process, physicists often describe black holes as waterfalls made of space itself. Far from the black hole, space flows gently, and escape is possible. But as one moves closer, the current strengthens. Near the event horizon, space rushes inward at ever-increasing speed. At the boundary itself, space falls inward at the speed of light. And since nothing can move faster than light, there is no swimming upstream. Once an object reaches the edge, it is carried along by the flow of space itself, descending silently into the depths. Here, in this quiet and relentless motion, the black hole reveals its true nature, not as a sudden devourer, but as a patient force, reshaping reality with calm inevitability. The seekers of darkness, the history of an idea. Black holes did not suddenly emerge in human awareness. They are the quiet result of centuries of careful thought, uncertainty, and intellectual courage, an idea slowly taking shape in the darkness. The silent beginning. The story begins in 1784, when the English clergyman and natural philosopher John Michell first imagined objects so dense that even light itself could not escape their grasp. He called them dark stars, a notion far ahead of its time. A little more than a decade later, in 1795, the French scientist Pierre Laplace arrived independently at a similar conclusion, using the tools of classical mechanics. Yet these early insights quietly faded from memory. As scientists began to understand light as a wave, the idea of trapping it seemed implausible, and the universe returned, at least temporarily, to a more comforting simplicity. Einstein and Schwarzschild. Everything changed in 1915, when Albert Einstein published his general theory of relativity. For the first time, gravity was no longer a force acting across space, but a curvature of space-time itself. Within this new framework, the door to black hole physics was finally opened. Only months later, amid the turmoil of war, physicist Carl Schwarzschild discovered the first exact mathematical solution to Einstein's equations, one describing an object with a point mass and an inescapable boundary. Ironically, Einstein himself remained deeply skeptical. He believed that nature would never permit such extreme entities to exist outside mathematics. The name black hole. For many decades, black holes lingered in theory alone, often referred to as frozen stars, little more than mathematical curiosities. That changed in 1967, when physicist John Wheeler formally introduced the term black hole during a public lecture. Its stark simplicity captured both scientific and public imagination. The phrase had appeared earlier in journalism, first used by reporter Anne Ewing in 1964, but Wheeler's adoption gave it permanence. From that moment on, the black hole became more than an equation. It became a presence, from theory to reality. In 1971, the mysterious X-ray source Cygnus X1 was identified as the first strong black hole candidate. With this discovery, black holes crossed the threshold from speculation into observation. What was once debated became undeniable. Darkness, it turned out, was real. You have now stepped quietly through the doorway to the void. You have seen how darkness is born from the fading of immense light, how space-time bends until it nearly breaks, and how generations of human thought patiently followed a shadow across centuries. Let the images of collapsing giant stars and silent horizons settle gently in your mind. Take comfort in the knowledge that you remain a distant observer, safely held within the calm spiral of the Milky Way. Every mystery finds its answer in time, and every journey deserves a place to rest. Allow your thoughts to drift with the slow, majestic collapse of the stars. In the universe, collapse is never an ending, only the opening of a new chapter in creation. Relax, unwind. Let the vastness carry you gently into sleep. Are you still awake, night travelers? If you remain here, by the quiet warmth of our campfire, then let us continue this gentle journey together. In the previous chapter, we stood before the gateway to nothingness, watching colossal stars surrender their light to become singularities of immense power. Now, allow your breathing to settle into a slow, steady rhythm. Together, we will drift 26,000 light-years through veils of cosmic dust toward the source of all motion, the pulse of the galactic heart, the silent conductor, Sagittarius, a star. Deep within the Milky Way rests Sagittarius, a star, a supermassive black hole whose presence humbles the imagination. If the Milky Way were a vast symphony played by billions of stars, Sagittarius A star would be its silent conductor, holding the orchestra together and preventing the music from dissolving into chaos. The weight of the giant. Careful measurements reveal that Sagittarius A star possesses a mass 4 million times greater than that of our Sun. Yet all of this immense weight is compressed into a region smaller than the orbit of Mercury. From such concentration arises a gravitational authority of staggering strength, commanding the motions of millions of stars in the galactic center and sending them racing around the core at breathtaking speeds. A deceptive calm. At present, Sagittarius, a star, exists in what astronomers describe as a quiescent state. It does not blaze like the distant quasars seen in other galaxies. Only a thin trickle of matter spirals quietly into its grasp. But this stillness is not weakness. It is restraint, the calm surface of a force that has not forgotten how to awaken. Giant burps, and the memory of violence. Though it now appears subdued, Sagittarius A star has left unmistakable marks upon the history of our galaxy. In March 2019, observations from the XMM Newton Space Telescope revealed vast X-ray emitting chimneys extending some 500 light-years above and below the galactic center. Chimneys of fire and gas. These towering structures resemble immense fountains of energized gas rising from the heart of the Milky Way. They form when infalling matter is heated to extreme temperatures within the accretion disk, releasing energy so intense that some material is driven outward instead of vanishing into the black hole. The reach of these chimneys is astonishing, more than 1 million times the distance between the Sun and Neptune. The Fermi bubbles. Most striking of all are the Fermi bubbles, 2 colossal lobes of gas filled with gamma radiation, each stretching nearly 25,000 light-years from the galactic center. Scientists believe these immense forms are the lingering echoes of a violent feeding episode that occurred roughly 6 million years ago. During that time, Sagittarius A star consumed vast stores of gas and dust, then unleashed powerful jets that swept material far from the galaxy's core, leaving behind the luminous scars we observe today. Now, night travelers, let these images drift softly through your thoughts. The quiet conductor at the center of it all, the ancient outbursts frozen in space, the slow breathing of a galaxy held together by an unseen hand. You are safe here, merely listening, as the universe tells its deepest stories in a voice barely louder than a whisper. The coordinator of stellar life, Sagittarius, a star, is not merely a cosmic destroyer. In a quieter, deeper sense, it is also a regulator of life among the stars. Black holes, paradoxical as it may sound, serve as unseen conductors, guiding the rhythm of an entire galaxy. Holding back the birth of stars. The powerful jets and winds released by black holes carry vast amounts of energy into their surroundings. When this energy heats the interstellar gas beyond a critical point, the gas can no longer collapse under its own gravity. Without collapse, stars cannot form. This is why the central region of the Milky Way, despite its abundance of material, produces new stars at a surprisingly low rate today. Awakening new beginnings. Yet destruction is never the whole story. As these same streams of energy travel outward, they can compress distant clouds of gas, gently squeezing them until gravity takes hold once more. In 2017, observations from the ALMA telescope revealed signs that a new generation of stars was slowly emerging, born not in spite of violence, but because of it, deep within this turbulent region. It is this delicate balance between heat and cold, restraint and release, destruction and creation, that has sculpted the Milky Way into the galaxy we quietly admire tonight. A swarm of black holes and cosmic parasites. Sagittarius, a star, is likely not alone in the galactic core. Long-term observations from the Chandra X-ray Observatory have uncovered a more unsettling truth. A dense gathering of smaller black holes lurks around this silent conductor. The hidden predators. Within just 3 light-years of the galactic center, astronomers have identified around a dozen stellar mass black holes through their X-ray emissions. These objects often reside in binary systems, bound to companion stars. Slowly and relentlessly, they strip material from their partners, drawing it inward. As this stolen matter heats up, it shines fiercely in X-rays, a final luminous cry before disappearing forever. The true scale of this population is staggering. Scientists estimate that as many as 20,000 stellar mass black holes may be packed into this small region. Over time, they drift inward from across the galaxy through a process known as dynamical friction, much like stones sinking quietly to the bottom of a still pond. Antimatter fountains and lingering mysteries. The galactic center is also home to one of the universe's most extraordinary phenomena, vast fountains of antimatter. In 2017, astronomers detected antimatter production on an almost unimaginable scale, nearly 10 trillion tons every second. When matter meets antimatter, both vanish in a flash of pure energy, releasing powerful gamma rays. At first, Sagittarius A star itself seemed a likely culprit, but the immense size of these fountains, stretching across thousands of light years, told a different story. The most plausible source is titanium-44, a highly radioactive element created when 2 white dwarf stars collide and explode. These rare supernovae occur more frequently in the galactic disk, the region where our own solar system resides, than in the crowded core. And so we are reminded, night travelers, that even from our quiet place on the outskirts, we are part of a galaxy forever alive with hidden fires. Beyond the calm darkness of our skies, antimatter flares, black holes gather, and creation and destruction continue their slow, eternal conversation. The death dance of the S-stars. To confirm the presence of Sagittarius A star, scientists did not stare into the darkness itself. Instead, they listened to the light, the quiet, faithful glow of the stars held captive by its gravity. These are known as the S-stars. Among them, the most famous is S2. Every 16 years, S2 completes a daring passage, sweeping past the invisible giant at a distance of only 17 light hours. At that moment, the immense gravity of Sagittarius A star hurls the star forward at a staggering speed, nearly 17 million miles per hour, or about 7,650 kilometers per second. At such velocity, A journey from New York to Los Angeles would take less than a heartbeat. In 2018, as S2 reached its closest approach, astronomers observed a subtle yet profound effect: gravitational redshift. The star's light was stretched by the intense gravity it escaped from, shifting gently toward the red end of the spectrum. This phenomenon, long predicted by Einstein, offered calm but undeniable proof. At the heart of our galaxy, there truly exists a supermassive black hole, silent, unseen, yet sovereign. Magnetic storms and cosmic lanterns. Encircling Sagittarius, a star, is a restless accretion disk, a swirling realm of chaos and heat. Here, temperatures soar so high that electrons are torn from atoms, transforming ordinary gas into glowing plasma and giving rise to immense magnetic fields. Magnetic storms. These magnetic fields twist and tangle like tightly wound piano strings. When the tension becomes too great, they snap. In that instant, colossal flares of infrared and X-ray light erupt into space. These storms dwarf anything produced by our sun, millions of times more powerful, releasing energy equivalent to 10 million volcanic eruptions igniting at once. Cosmic flashlights. The glowing clouds of superheated gas act like distant lanterns, casting their light back toward Earth. By following their motion, scientists have learned something remarkable. We are observing the accretion disk almost face-on, as though from above. Any burst of energy released from the core would be directed outward along this plane. And yet, at a distance of 26,000 light-years, our planet rests in complete safety, untouched by these distant outbursts. The fated union of two giants. The Milky Way does not dance alone forever. Beyond its spiral arms, another great galaxy approaches, Andromeda, moving toward us at more than 200,000 miles per hour. In 4 to 5 billion years, the two galaxies will begin their long, inevitable collision. Amid this grand convergence, Sagittarius A star and Andromeda's own supermassive black hole will find each other. They will spiral inward, locked in a tightening embrace, circling faster and faster, eventually approaching half the speed of light. When these two giants finally merge, space itself will tremble. Vast gravitational waves will ripple outward, shaking the very fabric of space-time. From this cosmic union, a new and even greater black hole will emerge, the beating heart of a single vast galaxy born from the remnants of two. A quiet ending. You have heard the pulse of the galactic heart. You have seen Sagittarius a star, not as a lifeless void, but as a quiet guardian, feeding, breathing, and shaping the destiny of billions of stars. In this immense cosmic ocean, it is the anchor that holds everything together. Now let the images fade gently, brilliant jets dissolving into darkness, towering gas bubbles drifting silently, stars tracing graceful arcs through space. Feel the comfort of knowing that this powerful presence maintains order, far from where you rest. You are safe here, in a peaceful galactic suburb, distant from all turbulence. Relax, breathe slowly, and allow yourself to drift into the eternal stillness of the stars. Our bonfire still burns, steady, warm, and quietly radiant. And if you are still awake, night travelers, let us continue our silent passage into the deeper reaches of the universe. Together, we have witnessed the violent birth of black holes from the ashes of dying stars, and we have listened to the slow, majestic heartbeat of Sagittarius a star at the center of the Milky Way. Now, allow your breathing to soften. Let calm flow gently from the crown of your head, across your shoulders, and down to your fingertips. We are standing at the edge of understanding, where darkness is no longer an ending, but the birthplace of insight. Welcome to Light from the Shadows, a chapter that tells how humanity learned to see the unseen, to sense the faint breath of black holes, and to contemplate the long, patient destiny of the universe. Let your thoughts drift with the quiet whispers of space, and allow yourself to sink deeper into rest as this story unfolds. Light from the Dark. The history of the seekers of darkness. Black holes did not suddenly appear before our instruments and lenses. Long before giant telescopes reached toward the heavens, black holes existed as quiet seeds within the human imagination, born not of sight, but of thought. The first dark stars. In 1784, the English clergyman John Michel proposed an idea both daring and unsettling. He reasoned that if a star were massive and dense enough, its gravity could become so strong that even light, the fastest traveler in the universe, would be unable to escape its surface. He called such objects dark stars. Only a decade later, in 1795, the French scientist Pierre Laplace arrived independently at a similar conclusion, suggesting that some of the brightest objects in the cosmos might paradoxically be completely invisible to us. The rise of relativity. The true foundation of black hole physics was laid much later, in 1915, when Albert Einstein published his general theory of relativity. In it, gravity was no longer a simple force of attraction, but the gentle, and sometimes violent, curving of space and time itself. Just months afterward, amid the chaos of World War I, physicist Carl Schwarzschild discovered the first exact solution to Einstein's equations. His mathematics described an object compressed to an extreme limit, a point where gravity became overwhelming. Yet even Einstein hesitated. He believed such strange solutions were mathematical curiosities, not things nature would ever permit to exist. From theory to reality. It was not until the 1960s that black holes emerged from abstraction into acceptance. Scientists came to realize that these objects were not anomalies, but unavoidable consequences of relativity itself. In 1967, John Wheeler gave them a name that would endure: black hole, simple, evocative, and impossible to forget. Then, in 1971, theory met observation. The object known as Cygnus X1 became the first confirmed black hole, revealed not by sight, but by its influence, drawing matter from a nearby blue giant star, causing that stolen material to glow fiercely in X-rays. And so, from quiet speculation to undeniable reality, humanity learned to recognize darkness, not as emptiness, but as presence. A presence that speaks softly, bends time itself, and continues to guide our understanding of the universe. Now let that understanding rest gently in your thoughts. The fire still burns, the night remains vast, and the universe continues to whisper its oldest truths, the moment of touching the event horizon. Although we have long known that black holes exist, humanity has always yearned to glimpse their true face. The greatest challenge lies in a simple truth. Black holes themselves emit no light. What we see instead is their presence, revealed only by a dark imprint, a shadow cast against the brilliant glow of the matter that surrounds them. The Event Horizon Telescope. To capture an image of a black hole, one would need a telescope as large as the Earth itself. Since such a structure could never be built, scientists turned to a quieter, more elegant solution. They linked 8 observatories across the globe, from the frozen silence of Antarctica to the volcanic heights of Hawaii, into a single synchronized instrument. This remarkable collaboration became known as the Event Horizon Telescope, or EHT. In April 2019, the world paused when the first direct image of a black hole was revealed. It showed the supermassive black hole at the center of the galaxy M87, some 55 million light-years away. At its heart lay a deep, perfect darkness, encircled by a glowing ring of gas heated to millions of degrees. That central void was the shadow of the event horizon, the place where light itself is lost forever. 3 years later, in May 2022, humanity was once again astonished. This time, the image revealed Sagittarius A star, the black hole at the center of our own Milky Way. Although much closer than M87 star, Sagittarius A star is far smaller, causing the surrounding matter to whirl and brighten in a matter of minutes. Photographing it was like trying to capture a restless figure in near total darkness. Yet the effort succeeded, confirming that Einstein's predictions about the shape of black holes hold true across all scales, from the immense to the intimate. The lullaby of Hawking's light, black holes are often imagined as silent devourers, endlessly consuming all that comes too near. But in the 1970s, physicist Stephen Hawking transformed this view with a revelation both subtle and profound. Black holes, in their own way, can shine. Hawking radiation and evaporation. According to Hawking's theory, the boundary of the event horizon is not entirely calm. In the quantum realm, pairs of virtual particles constantly flicker into existence, only to vanish almost instantly. On rare occasions, one particle falls into the black hole, while its partner escapes into space as heat. This faint release of energy is known as Hawking radiation. Because energy is being lost, mass must be lost as well. And so, black holes are not eternal. They slowly evaporate, like droplets disappearing beneath a distant sun. This process is unimaginably slow. A black hole with the mass of our sun would require around 10 to the power of 64 years to vanish completely. Supermassive black holes, such as Sagittarius A would endure for about 10 to the power of 100 years, spans of time so vast they defy human comprehension. The information paradox. Hawking's discovery also opened the door to one of the deepest puzzles in modern physics, the black hole information paradox. If a black hole eventually evaporates, what becomes of the information contained in everything it has consumed? The structure of a star, the composition of a planet, the subtle patterns of matter itself. Quantum mechanics insists that information can never be destroyed. Yet Hawking's original calculations suggested that it might be erased forever. This contradiction has sparked decades of debate, drawing some of the greatest minds in physics into a quiet, ongoing conversation about the true nature of reality. Now, let these thoughts settle gently. The darkness is no longer empty. It glows softly with questions, with patience, with time. And beneath the vast night sky, the universe continues to sing, slowly, quietly, and without end. The page curve and the salvation of information. In recent years, a quiet sense of hope has begun to emerge in the long search for an answer to the information paradox. Scientists are gradually coming to believe that black holes do not simply erase everything they consume. Instead, information may be preserved, hidden within structures of staggering complexity, far beyond ordinary intuition. The page curve. Physicist Don Page proposed a mathematical description that gently reshaped our understanding. At first, as a black hole emits Hawking radiation, the entropy of that radiation steadily increases, just as one might expect. But there comes a critical moment, known as the page time, when the process subtly changes. From that point onward, the black hole begins to return information to the universe. The entropy of the radiation slowly decreases, and by the time the black hole has completely evaporated, all the original information has been released, reborn within the radiation itself, scattered and disordered, yet not lost. The islands within the darkness. In 2019, new research revealed an even more intriguing idea, known simply as islands. Scientists realized that the deep interior of a black hole can, in a sense, belong to the radiation far outside it. This suggests that with a sufficiently powerful quantum computer, capable of deciphering Hawking radiation, it would be possible to reconstruct what lies inside a black hole without ever crossing the event horizon. This insight offers strong evidence that the universe obeys a profound rule. Nothing is truly forgotten, and conservation remains unbroken, even in the deepest darkness. Brothers in the mirror, white holes and wormholes. To soften the weight of these paradoxes, allow your thoughts to wander toward ideas even more unusual than black holes, their mirror counterparts. White holes. From a mathematical standpoint, If a black hole is a region from which nothing can escape, then relativity permits the existence of its opposite, the white hole. A white hole is a region into which nothing can enter, while matter and energy continuously flow outward. It is as if the life of a black hole were played backward in time. Some physicists, including Carlo Rovelli, have suggested a compelling possibility. When a black hole evaporates down to an extremely small size, it may undergo a quantum transformation, becoming a white hole that releases all the information it has gathered over billions of years. Wormholes. If a black hole and a white hole were connected, the result would be a wormhole, also known as an Einstein-Rosen bridge. Such a structure would form a shortcut through space and time. A journey that might take light millions of years could, in principle, be completed in mere hours. Though no wormholes have yet been observed, and they are believed to be highly unstable, their mathematical existence continues to inspire those who sense a deep interconnectedness woven into the fabric of the universe. The eternal sleep of the universe. The story of black holes is, ultimately, a story about endings, about the distant fate awaiting everything that exists. The black hole era. Imagine a future so remote that the last stars have long since burned out. After trillions of years, the universe will enter an age where black holes are the final inhabitants. They will stand as the last quiet strongholds of matter, remnants of once luminous galaxies. In the endless night, these giants will slowly drift together, merging and consuming one another, growing into colossal supermassive forms. The end of darkness. Yet even black holes are not eternal. Over immense spans of time, Hawking radiation will patiently strip away their mass. A supermassive black hole will shrink, becoming smaller and smaller until it is no larger than an atom. In its final moment, it will release a brief, brilliant flash, returning the last traces of matter and information to the frozen cosmos. And then, when the final black hole has vanished, the universe will fall into complete stillness. There will be no energy, no warmth, no motion, only a vast and tranquil emptiness. This is the heat death of the universe, an eternal sleep, silent and undisturbed, from which nothing will ever awaken. So now, you have completed your journey through the chapter Light from Darkness, witnessing how humanity's greatest minds patiently searched for black holes. Along the way, we discovered that black holes are not merely deadly traps in the cosmos, but profound keys, holding insight into the deepest workings of nature itself. You have walked beside humanity through the early doubts of Mitchell and Laplace, felt the quiet resilience of Schwarzschild, and listened to the distant prophecy of Hawking. You have gazed upon the shadow of a black hole through the eyes of the Event Horizon Telescope, and come to understand the quiet salvation of information revealed by the page curve. Now, allow all of this knowledge to settle gently within you, like a warm blanket drawn over a resting mind. Take comfort in the thought that no matter how vast, how dark, or how intimidating the universe may seem, it is governed by a perfect and beautiful order. You are part of that order. The matter that forms you carries the ancient memory of stars, of darkness, and of light. Relax now. Let your eyelids grow heavy. Feel the absolute silence slowly envelop the space around you. Are you still awake, night travelers? I suspect many of you have already drifted into sleep, wandering through magnificent visions of the universe in your dreams. Together, we have journeyed through the broad chapters of black holes and humanity's long quest to understand them. Now, our focus narrows. We turn our attention to the silent conductor and the peaceful suburbs, the story of our small home and its relationship to the powerful heart of the Milky Way. In this chapter, we will explore why we are here, in this quiet corner of the galaxy, and how a black hole tens of thousands of light years away quietly governs the rhythm of life across an entire galactic system. Let your thoughts begin to drift. drift gently toward the center of the Milky Way. The silent conductor and the peaceful suburbs. A map of silence. To understand our place in the cosmos, imagine the Milky Way as a giant pepperoni pizza. If the entire brilliant galaxy, with its hundreds of billions of stars, is that pizza, then everything visible to the naked human eye in the night sky fits neatly within a single slice. And within that single slice, our solar system is no more than a tiny grain of dust. We do not live in the crowded, restless center of the galactic city. Instead, our home rests in a calm and spacious suburb, a thin ribbon of stars known as the Orion Cygnus Arm, or the local spur. Here, stars are widely spaced, the darkness between them is vast, and our sun shines steadily for billions of years. This location is no accident. According to scientists, living in this outer region is a rare cosmic privilege. Had our solar system formed closer to the galactic center, life would face constant danger, intense radiation from frequent stellar explosions, violent currents of superheated gas, and powerful gravitational forces capable of disrupting planetary orbits without warning. But here, within Orion's arm, the Milky Way has quietly provided Earth with a natural sanctuary, a stable, safe zone where life has been able to emerge, endure, and evolve for over 4.5 billion years, undisturbed by major galactic catastrophes. Rest now in that thought. Safe, quiet, carried gently through space, a 26,000 light-year journey. Now, in your imagination, gently step away from this quiet suburb of the galaxy. We begin a long journey inward, toward the Milky Way's distant center. Picture yourself gliding upon a beam of light, racing forward at 300,000 kilometers per second. Even at that unimaginable speed, it would still take 26,000 years to reach the outer boundary of the galactic core. As you travel deeper, the scenery slowly transforms. Space is no longer calm or spacious as it was in the suburbs. Here, the environment grows restless and intense. Vast rivers of gas surge through the darkness. Bursts of high-energy radiation flash like distant lightning. Stars move at staggering speeds, weaving erratic paths as though caught in an endless and silent race. From within this swirling tapestry of color and motion, a presence reveals itself, the entity we call the heart of the galaxy, Sagittarius A star, or SGR A star. This is no ordinary star. It is a supermassive black hole, a silent and invisible giant, carrying a mass 4 million times greater than that of our sun. And yet, all of that unimaginable weight is compressed into a region of space smaller than our own solar system. Here, SGR A star serves as an absolute gravitational anchor, holding billions of stars in their orbits and preventing the Milky Way from unraveling into the cold emptiness beyond. The conductor and the galactic chimneys. Although scientists describe SGR A star as being in a quiescent state, it is far from inactive. It resembles a conductor standing quietly after a grand symphony, seemingly still, yet every subtle gesture continues to guide the entire orchestra. In March of 2019, the XMM Newton Space Telescope uncovered a remarkable secret of this silent conductor. Rising from the region around SGR A star, two immense columns of gas, glowing brightly in X-rays, extend some 500 light-years above and below the black hole. These towering structures are known as X-ray chimneys, and they stand as clear evidence that the galactic heart is releasing vast amounts of energy. How does this occur? When wandering clouds of gas are drawn inward by the black hole's gravity, they do not plunge directly into the abyss. Instead, they spiral around it, forming what scientists call an accretion disk. Within this swirling disk, friction and extreme heat the gas to millions of degrees, unleashing enormous energy. Some of this superheated matter escapes capture. Rather than being consumed, it is hurled back into space, carving out colossal jets of energy that rise like chimneys from the galactic center. This is how Sagittarius, a star, breathes, quietly releasing the immense pressure that builds deep within its unseen heart. Let that image settle in your mind, a silent giant, breathing slowly, keeping the rhythm of an entire galaxy. Scars of the past, Fermi bubbles. If the 500 light-year tall X-ray chimneys overwhelm you, look even further. These chimneys appear to connect to the two largest structures ever discovered in the galaxy, the Fermi bubbles. Each bubble is up to 25,000 light-years long, a distance roughly equivalent to the distance from Earth to the galactic center. The presence of these giant gas bubbles filled with gamma rays tells us a story about Sgr-A's violent past. About 6 million years ago, this maestro may have experienced a feeding frenzy. It devoured too much matter and fired powerful jets at near-light speeds. These energy streams swept gas out of the galactic center, leaving behind the brilliant scars we observe today. Sgr-A star has truly shaped the galaxy's form. These bursts of energy aren't just destructive, they're like a sculptor's blade, trimming and shaping the distribution of matter in space. The coordinator of star life. Sgr-A star acts as a coordinator of whether or not new stars are born. Supermassive black holes act as a temperature control system for galaxies. The obstruction. When a black hole ejects jets of energy, it heats the surrounding gas to extreme temperatures. Overheated gas cannot contract to form new stars. This is why the current star formation rate in the Milky Way is very low. The beginning. However, in 2017, the ALMA telescope observed something miraculous. Right in the midst of the destructive landscape near the black hole, a new generation of stars was quietly beginning to form. This shows that our conductor sometimes helps compress the gas clouds, triggering the birth of new suns. It is this delicate balance between heat and cold, between the present stillness and the past furies of Sgr-A star, that creates a stable galactic environment for us. If Sgr-A star did not exist, the Milky Way would likely have disintegrated or become uninhabitable. The shield of the suburbs, returning to our little home in Orion's arm. Though far from the turbulent heart of the galaxy, the solar system is equipped with miraculous protective layers to ensure our slumber is never disturbed. The solar system is enveloped in the solar magnetosphere, heliosphere, a giant bubble created by the continuous stream of particles from the sun, shielding us from much of the harmful radiation from interstellar space. And on Earth, we have a robust magnetic field and a thick atmosphere. These shields not only protect us from stray debris, but also block high-energy ultraviolet and cosmic rays that could originate from the activity of the central black hole itself. Therefore, even if Sgr-A roars or shoots out record-breaking X-ray beams as it did in 2015, we are still perfectly safe here. The distance of 26,000 light-years is the strongest protective wall nature has given humanity. You have seen the image of a powerful yet silent conductor, Sagittarius, a star, quietly maintaining the rhythm of the galaxy. And you have seen our own quiet fortune, living in a gentle suburb of stars, where light and shadow meet in harmony. Now, allow your breath to deepen. Feel the complete stillness settling around you. That great conductor remains awake, watching over the night, holding every star in its proper place. Everything is as it should be. You are safe. Let go, and sink slowly into the calm embrace of the darkness. We have already witnessed the tragic collapse of giant stars, their final moments giving birth to powerful black holes. Now, let your body sink a little deeper into the comfort of the bed. Release the tension in your shoulders. Relax each finger. Let your breathing find its natural rhythm, like gentle waves rolling onto a quiet shore. Together, we will travel 26,000 light-years, gliding through soft clouds of dust and gas, toward the very heart of motion itself. This is Act 2, echoes from the darkness and fleeting fury. This is the story of an unseen presence, silently conducting the vast orchestra of the Milky Way, the great Sagittarius, a star. Let your mind rest in the steady rhythm of the void, echoes from the darkness and fleeting fury. Deep within the Milky Way lies a region unlike any other. It is the strangest, the most turbulent, and the most extreme environment in our entire galaxy. Here, rivers of gas surge through space, high-energy radiation flashes without warning, and stars race chaotically, like grains of dust caught in a restless wind. Yet at the very center of this cosmic unrest resides an invisible giant, Sagittarius, a star, the supermassive black hole at the core of our galaxy. Imagine an object with a mass 4 million times greater than that of the Sun, yet compressed into a region of space smaller than Mercury's orbit. From this extraordinary concentration arises an immense gravitational force, powerful enough to hold billions of stars in their paths and shape the graceful spiral of the Milky Way itself. Today, scientists describe this giant as a quiescent black hole. It does not blaze like the distant quasars seen in other galaxies. It does not roar. Instead, it rests in a long, quiet slumber, occasionally drawing in small amounts of wandering gas and dust. But do not mistake this calm for insignificance. Even in silence, its influence reaches far and wide. Everything that unfolds at this hidden center is woven into the destiny of the entire Milky Way, including our small, distant solar system, resting peacefully in the night. Although Sagittarius, a star, appears calm and restrained today, its past tells a far more turbulent story, one marked by sudden and terrifying outbursts. In March 2019, when scientists aimed their X-ray telescopes toward the galactic center, they uncovered something extraordinary: two vast structures known as X-ray chimneys. These glowing pillars rise nearly 500 light-years above and below the black hole. They resemble immense fountains of gas, quietly pouring energy back into the surrounding galaxy. Scientists describe this phenomenon as the black hole burping after a heavy meal. As gas and dust spiral inward through the accretion disk, friction and extreme speed heat the material to millions of degrees. Not all of it is swallowed. Some of that energy is expelled outward, escaping the pull of darkness and returning to space. Yet even these chimneys pale beside a far grander testament to the black hole's past, the Fermi bubbles. These are two colossal lobes of gas, filled with gamma rays, each stretching some 25,000 light-years beyond the galactic disk. Their presence tells a dramatic story. About 6 million years ago, Sagittarius A likely entered a violent feeding episode, devouring vast amounts of matter and launching powerful jets at nearly the speed of light. Those jets swept enormous volumes of gas away from the galactic center, leaving behind the luminous scars we observe today. These structures remind us that black holes are not merely destroyers. They are sculptors, quietly shaping the structure and long-term evolution of our shared galactic home. Sagittarius A star does more than consume. It acts as an orchestrator, guiding the slow rhythm of stellar life and death. First, it can prevent stars from being born. The immense energy released by black hole jets heats the surrounding gas. When gas becomes too warm, it can no longer collapse under its own gravity. This is one reason why star formation near the galactic center is so subdued today. And yet, there is another side to this influence. Under the right conditions, those same streams of energy can compress drifting clouds of gas, creating the quiet beginnings of new suns. In 2017, astronomers observed young stars forming silently within the turbulent environment near the galactic center. A gentle reminder that creation can arise even in the shadow of destruction. It is this delicate balance between heating and cooling, between suppression and renewal, that allows the Milky Way to remain stable. Without the steady orchestration of this silent conductor, our galaxy might never have achieved its graceful form. And Sagittarius, A star, is not alone in the darkness. 12 years of observations from the Chandra X-ray Observatory have revealed a striking truth. A swarm of black holes surrounds the galactic center. Scientists have already identified 12 small, stellar-mass black holes within a radius of just 3 light-years, and they estimate that as many as 20,000 may be hidden there. Drawn inward by a process known as dynamical friction, these objects drift toward the center over time, much like stones sinking to the bottom of a still pond. Many of these smaller black holes live as quiet predators. Often paired with companion stars, they slowly strip away their partner's outer layers, drawing matter inward. As that stolen material falls toward the black hole, it heats up and shines brightly in X-rays, brief flashes of light that betray the presence of these invisible vampires in the vast ocean of stars. And so, even in silence, the heart of the galaxy remains alive, breathing, shaping, and guiding the long night of the Milky Way. Although Sagittarius A star itself remains unseen, it occasionally makes its presence known through brief, luminous signals, quiet bursts of light known as flares. These storms are born within the accretion disk, where magnetic fields grow extraordinarily strong. At such extreme energies, electrons are stripped from atoms, transforming ordinary gas into a blazing state of plasma. Scientists often compare these magnetic fields to a tightly tangled bundle of piano strings. As the strings twist ever tighter, tension builds, until, without warning, they snap. In that instant, an immense release of energy occurs, equal to millions of solar flares erupting at the same time. These flares act like distant flashlights, momentarily shining back toward Earth. By carefully studying them, astronomers have confirmed that we are viewing the accretion disk almost directly. In 2015, Sagittarius A released a record-breaking X-ray flare, 400 times stronger than its usual output. Yet even this outburst posed no danger. At a distance of 26,000 light-years, Earth remains safely cradled in calm and silence. At the galactic center, another strange and subtle phenomenon unfolds: the appearance of antimatter fountains, the enigmatic mirror image of ordinary matter. Antimatter is the most potent explosive substance known. When it encounters matter, both are annihilated, releasing torrents of powerful gamma rays. Scientists have discovered that this region of the galaxy produces up to 10 trillion tons of antimatter every second. At first, Sagittarius A star was suspected as the source. But the scale of these fountains, stretching across thousands of light-years, proved too vast. The true origin appears to lie in the deaths of stars. The radioactive element titanium-44 is created during collisions between white dwarf stars. These explosive events occur more frequently in the galactic disk, the same region where our solar system resides. It is a gentle reminder that even in the galaxy's peaceful outskirts, extraordinary displays of energy continue to unfold. To confirm that Sagittarius A star is truly a black hole, scientists turned not to darkness, but to the stars moving around it, objects known as S stars. The most famous among them is S2. Every 16 years, S2 embarks on a daring passage, sweeping past the black hole at a distance of just 17 light-hours. The conductor's immense gravity hurls the star forward at a staggering speed of 17 million miles per hour, about 7,650 kilometers per second. At that velocity, a journey from New York to Los Angeles would take less than half a second. In 2018, as S2 reached its closest approach, astronomers observed gravitational redshift exactly as Albert Einstein had predicted. The star's light was stretched by the intense gravity, shifting toward the red end of the spectrum. This observation did more than confirm the existence of the dark giant at the center. It affirmed that the universe moves according to precise and elegant mathematical laws. In 2011, anticipation swept through the global astronomical community with the discovery of a gas cloud named G2, racing toward Sagittarius A star. Many believed this would be the long-awaited moment, the first time humanity would directly witness a black hole feeding. Predictions suggested that by 2014, G2 would be torn apart, producing a brilliant display as it crossed the event horizon. Instead, an unexpected calm followed. The cloud passed remarkably close to the black hole and emerged largely intact. Why did this encounter remain so quiet? Some scientists now believe G2 was not merely a cloud of gas, but a star wrapped in a thick gaseous shell, or the remnant of a stellar merger. The hidden star's gravity may have held the material together, preventing it from being consumed. It was a quiet reminder, spoken softly across the void, that the universe still keeps many secrets, ones that even our most advanced theories and machines have yet to fully understand. Our Milky Way galaxy is not alone in the vastness of space, and far in the quiet future, it is preparing for one of the greatest events in its long history, a meeting with its neighbor, Andromeda. Andromeda is drifting toward us at more than 320,000 kilometers per hour. In roughly 4 to 5 billion years, the two galaxies will begin a slow and graceful merging. When that time arrives, our silent conductor, Sagittarius A star, and the supermassive black hole at the heart of Andromeda will enter a solemn and inevitable dance. They will circle one another, drawing ever closer, their motion accelerating until it reaches nearly half the speed of light. The union of these two giants will release a tremendous surge of energy in the form of gravitational waves, subtle yet powerful ripples that will pass through the fabric of space and time itself. Our solar system may be gently cast toward the outer edges of the newly formed galaxy, but it will remain unharmed. From this cosmic marriage, a new and even more powerful black hole will be born, becoming the steady heart of a vast, reborn galaxy. You have come to see Sagittarius A not as a cold and lifeless void, but as a living presence, breathing, feeding, and quietly guiding the rhythm of billions of stars. It is the most enduring anchor in this immense cosmic ocean. Now, allow yourself to rest in the comfort of knowing that this giant, however powerful, lies 26,000 light years away. From that distance, it silently preserves the balance of our galactic home. Here, in a peaceful suburb of the Milky Way, you are safe. Let the images of radiant energy streams and the graceful motion of stars calm your thoughts. Relax completely. Breathe slowly and evenly, and drift into the deep, eternal stillness of the dark. Night travelers, are you still here? For those who remain, let us continue our quiet passage into the depths of the universe, where time itself slows and the final chapters of a great cosmic story begin to unfold. After witnessing the powerful heartbeat of the black hole at the galactic center, I invite you now to release all tension, allowing your breath to move like a soft breeze among the stars. Tonight, we step into the dance of destiny and the eternal sleep of the universe. This is a story of final encounters, of matter gently dissolving, and of a cosmos that slowly, peacefully comes to rest. Let the vastness of space soothe your mind, and allow the lullaby of distant galaxies to guide you into a deep and restful sleep. The dance of destiny and the eternal sleep of the universe, the great marriage between two galaxies. The story of our distant destiny begins with a quiet but profound truth. The Milky Way is not alone in the vast ocean of space. Some 2.5 million light-years away, the Andromeda Galaxy is already on an unavoidable path toward us. Careful measurements have shown that Andromeda is approaching the Milky Way at a speed exceeding 320,000 kilometers per hour. At first glance, this velocity sounds violent and overwhelming. Yet on the grand scale of the cosmos, it is a slow, steady, almost ceremonial movement. Nearly 5 billion years must pass before the two galaxies finally meet. By that time, our sun will have entered the late chapter of its life, expanding and scorching its inner worlds. But beyond the fate of planets, a far greater transformation will be unfolding across the galaxy itself. As the Milky Way and Andromeda begin to merge, their immense gravitational forces will gently but relentlessly unravel both structures. The stars themselves will not collide. The distances between them are far too vast, but their orderly paths will be profoundly altered. Entire stellar systems will be cast into new trajectories. Our own solar system is likely to be carried toward the outer reaches of a newly forming galaxy, drifting quietly amid the luminous debris. At the heart of this majestic upheaval, two colossal conductors will find each other at last. Sagittarius, a star, the supermassive black hole at the center of the Milky Way, and its counterpart within Andromeda. Their encounter marks the beginning of a solemn and fateful dance, the spiral dance of the giants. The union of two supermassive black holes is among the most powerful events the universe can offer. At first, they will circle one another at great distances, their orbits lasting for vast spans of time. Yet with every revolution, they disturb the fabric of space and time itself, like ripples spreading across the surface of a silent lake. According to the laws of relativity, these immense objects do not merely move through space. They drag space along with them. As energy is gradually lost in the form of gravitational waves, the distance between the two giants slowly shrinks. Their motion becomes faster, more intense, until their spiraling speed approaches half the speed of light. The final moment of union will release an extraordinary surge of energy, greater than the combined light of all the stars in the galaxy. Gravitational waves will surge outward, stretching and trembling the very structure of space itself. Were any observers present at that distant time, they would see a brilliant and unforgettable glow at the heart of the newly formed galaxy. From this cosmic union, a new and even more powerful supermassive black hole will be born, an enduring ruler at the center of a unified galactic realm, marking the completion of one great chapter and the beginning of another in the long, quiet story of the universe. The Age of Silent Ghosts. Our universe is living through its most luminous chapter, an age powered by the steady light of countless stars. Yet even this brilliance is not eternal. Over unimaginable spans of time, the hydrogen fuel that sustains the stars will be gradually exhausted. One by one, the final lights will dim, leaving behind cold remnants, white dwarfs, neutron stars, or bodies that collapse inward to become black holes. When the last stars have faded, the universe will quietly enter a new and enduring era, the age of black holes. Lonely planets and the remains of dead stars will drift ever closer to the gravitational hearts of ancient galaxies. Drawn in by patience rather than force, they will be consumed by supermassive black holes in a slow and methodical process, as if the universe were gathering the final traces of its own history. In this distant age, black holes will stand as the last fortresses of matter. They will linger in profound darkness, occasionally merging with one another to form entities of staggering scale, perhaps hundreds of billions of times more massive than the Sun. For trillions of years, space will resemble a silent graveyard, where these cosmic ghosts quietly guard the remnants of a once radiant universe. Hawking's lullaby and the evaporation of darkness. Black holes are often imagined as immortal, the final and unchanging end of all things. Yet Stephen Hawking revealed a gentler, almost poetic truth. Even black holes slowly give something back. At the boundary of the event horizon, the strange rules of quantum mechanics allow pairs of virtual particles to appear and vanish without warning. Occasionally, one of these particles falls into the black hole, while its partner escapes into space, carrying away a tiny fraction of energy. This faint emission, known as Hawking radiation, means that black holes are not entirely silent. They are slowly exhaling, losing mass as if evaporating like a droplet under an unseen sun. For a supermassive black hole, this process unfolds at a pace far beyond human intuition. To fully evaporate would require roughly 10 to the power of 100 years, a number so vast that it escapes all ordinary comparison. Even if one were to count every grain of sand on Earth once every billion years, the count would be repeated countless times before such a black hole finally vanished. In this immense patience, the black hole is quietly returning to the universe what it once borrowed in the form of the faintest warmth. The last moments of nothingness. As a black hole nears the end of its existence, the rhythm changes. Evaporation accelerates. What was once a giant dominating the heart of a galaxy will shrink, first to the size of a mountain, then to something smaller still, until it is no larger than an atom. In its final instant, the black hole will release all its remaining energy in a brief, brilliant flash of light and gamma rays, the universe's last fireworks. When the final black hole disappears, space will be emptied of matter, of light, and of any active memory of what once was. The universe will then settle into what physicists call thermal death, a state of perfect stillness. Temperature will be nearly uniform everywhere, hovering close to absolute zero. There will be no motion, no energy exchange, only a vast and timeless calm. It is not a violent ending, but a gentle return to profound peace, a silence so complete that even time itself seems to rest. The legacy of information in the darkness. Even if the universe were to sink into absolute silence, there is one question that would continue to echo in the minds of scientists. Where does information go? When a black hole finally disappears, what becomes of the stories of our lives, of the stars that once illuminated the cosmos? According to the latest research, black holes do not erase the universe's memory. Through a remarkable mechanism known as islands, the deep interior of a black hole is subtly linked to the radiation that escapes into space. This connection suggests that every fragment of matter ever swallowed leaves behind a delicate imprint, encoded within Hawking radiation itself. Even after a black hole has vanished, the legacy of the universe endures, preserved as faint disturbances woven into the fabric of space-time. The universe may fall asleep, but it sleeps carrying every story it has ever written. Nothing is truly lost. Everything is transformed, continuing its quiet role in the endless symphony of existence. From the powerful heartbeat of Sagittarius, a star, to the final whisper of Hawking's light, you have witnessed the beauty of a universe governed by order, patience, and quiet wonder. Now, allow the images of slow galactic dances and tranquil event horizons to calm your thoughts. Feel both your safety and your smallness, a precious grain of sand resting within an immeasurable cosmic ocean. All mysteries move gently toward resolution, and all motion flows toward perfect stillness. The universe can be imagined as a vast, dimly lit room, where black holes are oil lamps slowly running out of flame. When the final flame fades, the room does not become frightening, only cool and silent, prepared for an eternal rest that nothing can disturb. Completely relax. Let your eyelids grow heavy. Drift softly into the peaceful darkness. By now, many night travelers have likely drifted into sleep, carrying with them a new understanding of black holes, no longer as villains, but as quiet participants in the universe's long story. For those who remain awake, I invite you to join me on one final journey and allow your mind to rest fully at ease. The diversity of darkness. Our universe is far from a monotonous void. It is more like an ancient forest, where each black hole stands as a tree of its own size, weight, and silent character. Scientists have come to understand that black holes are not all the same. They exist across a vast spectrum of mass and scale. Stellar mass black holes are the most common inhabitants of the cosmos. They are born from the collapse of massive stars and typically weigh several times more than our sun, yet are no larger than a city. Intermediate mass black holes occupy a mysterious middle ground, with masses ranging from 100 to 100,000 times that of the sun. They are rare and often found hidden within dense star clusters, as if quietly waiting to be discovered. Supermassive black holes are the true giants, weighing millions or even billions of times more than the sun. They rule the centers of large galaxies, shaping the motion of stars and the fate of cosmic matter around them. Beyond these, theory suggests the existence of primordial black holes formed in the very first moments after the Big Bang. Some may be no larger than a grain of sand, yet carry the mass of an entire mountain. A reminder that even the smallest things in the universe can possess extraordinary depth. And with that thought, let us rest, knowing that even in darkness, the universe is rich, diverse, and quietly alive. A galaxy full of singularities. Have you ever paused, late at night, and wondered how many black holes may be quietly drifting through our own Milky Way? The answer is both humbling and astonishing. Scientists estimate that millions of stellar mass black holes wander silently within our galaxy. Most remain completely invisible because they are not actively consuming matter and therefore emit no light. We only become aware of their presence when chance intervenes, when one passes close to a star or settles into a binary system, slowly drawing material from its companion in a quiet, relentless exchange. Near the galactic center, surrounding the silent conductor Sagittarius, a star, observations from the Chandra X-ray Observatory suggest something even more remarkable. Within a radius of just 3 light-years, there may exist a dense swarm of black holes, perhaps as many as 20,000, slowly drifting inward, guided by the subtle pull of gravitational friction. Imagine the Milky Way as a deep, dark ocean. We see only the gentle shimmer on its surface, while beneath, countless singularities quietly bend space itself, unseen and undisturbed. A shield and safety in silence. Hearing of millions of black holes may sound unsettling at first, but take a slow breath and rest easy. We reside in one of the calmest neighborhoods the galaxy has to offer. Our solar system lies about 26,000 light-years from the galactic center, a distance that places us well beyond any real danger. Even the nearest known black hole, Gaia BH1, remains roughly 1,560 light-years away, far too distant for its gravity to disturb your quiet night. The universe has positioned us with remarkable care, close enough to witness its grandeur, yet far enough to be sheltered within its vast stillness. Sagittarius A, our silent heart, at the very center of the Milky Way, hidden behind thick curtains of cosmic dust, rests Sagittarius, a star, the supermassive black hole we quietly call home. With a mass 4 million times greater than the Sun, SGR-A star is astonishingly compact, occupying a region smaller than the orbit of Mercury. To astronomers, it is a quiescent conductor, calm, restrained, and patient. It does not rage or feed violently like the black holes found in younger, more turbulent galaxies. From time to time, it gently stirs, releasing towering columns of superheated gas that rise nearly 500 light-years into space, forming faint X-ray smokestacks. Like an ancient guardian asleep at the center of the galaxy, SGR-A star keeps billions of stars moving in a slow, harmonious rhythm. Messier 87, the monster of the universe. To truly appreciate the quiet nature of Sagittarius A, we must look far beyond our galaxy, to the distant realm of the Messier 87, some 55 million light-years away. There resides M87 star. If SGR-A star is a conductor, then M87 star is a titan. With a mass 6.5 billion times that of the Sun, it outweighs our galactic center by more than 1,000-fold. Its event horizon is so vast that it could engulf our entire solar system many times over. While the accretion disk of Sagittarius A star flickers and shifts within minutes, making it extraordinarily difficult to photograph, M87 star presents a much larger and more stable structure. From its core erupt immense jets of energy, stretching thousands of light-years into intergalactic space, an overwhelming display of power that our own black hole no longer possesses. And so, as the night deepens, we are reminded of a quiet truth. We live not in a hostile cosmos, but in a carefully balanced one, surrounded by immense forces, yet gently protected by distance, silence, and time. Rest now. The galaxy is vast, but you are safe within it. The different faces of nothingness. When we place Sagittarius, a star, beside M87 star, we begin to sense the astonishing richness of the universe. In temperament, they could not feel more different. Sagittarius A star is calm and restrained, almost contemplative. M87 star, by contrast, radiates raw power, brilliant, fierce, and unapologetic. In appearance, they share a haunting similarity. Each reveals a glowing orange ring of superheated gas encircling a profound darkness, the shadow where light itself can no longer escape. Yet the emotions they stir are not the same. SGR A star feels intimate, familiar, the quiet heart around which our own destiny gently turns. M87 star, on the other hand, speaks of creation and destruction on an almost unimaginable scale. That both of these vastly different entities exist and behave exactly as predicted is a magnificent affirmation of Einstein's theory of relativity. Whether modest or immense, every black hole obeys the same elegant mathematical laws that govern space and time. The architects of the galaxy. Now, let your thoughts drift even farther. Beyond the Milky Way, beyond M87. Astronomers believe that nearly every large galaxy in the universe shelters a supermassive black hole at its core. With hundreds of billions of galaxies in the observable universe, this means there are hundreds of billions of silent rulers, each conducting the slow rhythm of stars across incomprehensible distances. Black holes are not merely cosmic traps, they are architects. By compressing clouds of gas, they can awaken the birth of stars. By releasing energy, they can just as easily bring that birth to a halt. Galaxies and their central black holes appear to grow together, shaping and reshaping one another over billions of years. Together, they form the principal voices in the universe's vast and ongoing symphony. The migration and fateful encounters. The universe is never truly still. Everything moves, everything drifts. From time to time, galaxies meet, and when they do, they merge. In these encounters, the supermassive black holes at their centers begin a slow, inevitable dance. They circle one another, stirring space-time itself, sending out gravitational waves that ripple through the cosmos. At last, they unite, giving birth to a single, even more powerful black hole. This is not merely a story of the distant past or far-off realms. Even now, the Andromeda Galaxy is moving steadily toward us. In 4 to 5 billion years, our own quiet conductor, Sagittarius A star, will meet its counterpart from Andromeda. It will be a moment of tremendous energy, fearsome, awe-inspiring, and yet also the beginning of something new, a larger, grander galaxy, and a renewed chapter in the long, patient story of the universe. Rest with that thought. The cosmos is vast, ancient, and endlessly changing. And tonight, you are simply a calm listener beneath its stars. Hawking's lullaby and the gentle return. Even the mightiest presences in the cosmos are not eternal. According to the quiet insight of Stephen Hawking, even black holes, those symbols of absolute finality, are slowly fading away. They release a delicate whisper of particles known as Hawking radiation. It is not a dramatic event, not an explosion, but a patient exhalation unfolding over unimaginable stretches of time. A black hole like Sagittarius, a star, would require around 10 to the power of 100 years, a number far beyond human intuition, to completely disappear. Long after the last stars have dimmed, after galaxies have grown cold and silent, black holes will remain as the final sentinels of the universe. For ages beyond counting, they will stand alone in the darkness. And then, quietly, without ceremony, they too will dissolve, returning their borrowed energy to the cosmos and bringing a vast cycle of existence to a gentle close. Let us pause for a quiet moment, and reflect on humanity. Or more precisely, on the scientists, the great minds who first dared to imagine the existence of black holes. Our story does not begin with vast observatories or powerful machines, but with the quiet strength of human thought. Black holes did not emerge suddenly in our understanding. They were born from centuries of careful reflection and intellectual bravery. In 1784, an English pastor and natural philosopher named John Michell proposed a remarkable idea. He reasoned that if a star were massive and dense enough, its gravity could become so strong that even light, the fastest traveler in the universe, would be unable to escape its surface. With poetic intuition, he called these hypothetical objects dark stars. Only a decade later, the French scientist Pierre-Simon Laplace arrived at the same conclusion independently. These thinkers imagined invisible worlds long before humanity possessed the instruments to observe them. Yet as science progressed and light came to be understood as a wave, the notion of light being trapped began to feel implausible. Gradually, the idea faded into obscurity, and the universe seemed once more simple, orderly, and calm. But this calm was only temporary, a quiet pause before a profound transformation. The ideas had not vanished. They merely lay dormant, like seeds beneath the soil, waiting for the right moment to awaken. That moment arrived in 1915, when Albert Einstein published his general theory of relativity. With it, the very language used to describe the universe was rewritten. Einstein no longer viewed gravity as an invisible force acting across empty space. Instead, he revealed a far more elegant picture: space and time woven together into a smooth, flexible fabric, shaped and curved by mass and energy. Gravity was no longer a pull, it was geometry itself. And within this new vision of reality, the doorway to black holes quietly opened. Just a few months later, amid the thunder and uncertainty of World War I, a quiet breakthrough occurred. The physicist Carl Schwarzschild found the first exact mathematical solution to Einstein's equations. In his work, he described an object compressed to an ultimate extreme, a point where gravity becomes so overwhelming that it creates a boundary from which there is no return. There is something deeply human in what followed. Albert Einstein himself was unconvinced. He believed that nature would never permit such extreme objects to exist in reality, that they belonged only to the abstract realm of mathematics. And yet, this is the quiet beauty of science. The universe sometimes turns out to be far stranger and far more daring than even its greatest thinkers had imagined. For many decades, these objects lingered as mathematical phantoms, known by the uninviting name frozen stars. They were equations without substance, ideas without a face. Then, in 1967, physicist John Archibald Wheeler gave them a name during a public lecture: simple, powerful, and unforgettable: black hole. In that moment, an abstract solution became something almost tangible, a presence rather than a formula. The journey from theory to reality was slow and patient, carried forward by generations of scientists. In 1971, the enigmatic X-ray source Cygnus X1 was confirmed as the first strong black hole candidate. Darkness, it seemed, was no longer just an idea, it was real. But humanity was not satisfied with knowing that black holes existed. We wanted to see them, and to do so, we embarked on one of the most remarkable collaborations in scientific history, the Event Horizon Telescope project. 8 observatories across the Earth were linked together, from the frozen silence of Antarctica to the volcanic heights of Hawaii, forming a virtual telescope as large as our planet itself. In April 2019, the world paused when the first direct image of a black hole was unveiled, taken from the heart of the M87 galaxy. A glowing ring of light surrounded a perfectly dark center, the unmistakable shadow of an event horizon. Then, in May 2022, we were astonished once more. Scientists revealed the image of Sagittarius, a star, the supermassive black hole at the center of our own Milky Way. Capturing it was like photographing a restless figure moving in near total darkness. Yet the image held steady, quiet, and profound. Together, these achievements confirmed something deeply comforting. Einstein's vision of the universe was correct, not just in theory, but in the living, breathing cosmos itself, at every scale and in the deepest darkness. We now stand at a gentle and promising threshold. Modern studies of Hawking radiation, the faint, almost imperceptible breath of black holes first revealed by Stephen Hawking, have taught us something quietly profound. Black holes are not immortal. Over inconceivably long spans of time, they slowly fade, returning their borrowed energy back to the universe. Future scientists will continue their patient work on the great information paradox. When matter falls into a black hole, is its story lost forever? Or is it carefully preserved within the subtle and complex structures known as islands, hidden deep in the darkness? We also allow ourselves to imagine even stranger possibilities. White holes, the mirrored counterparts of black holes where matter flows outward. Or wormholes, silent corridors that may one day offer shortcuts through space and time. Black holes, it seems, are not merely cosmic traps of destruction. They are keys, quiet, demanding keys, to understanding the deepest laws that govern nature itself. Tonight, you have traveled with me through a long and thoughtful journey of human understanding, from the early doubts of Jean Michel and Pierre-Simon Laplace, to the quiet determination of Carl Schwarzschild, the sweeping vision of Albert Einstein, and finally, the gentle prophecy of Hawking himself. You have seen how darkness is born from fading light, and how the human mind has followed a shadow with patience and courage for centuries. Now, allow all of this knowledge to rest softly within you, like a warm blanket settling over a tired spirit. There is no need to fear the vastness or the darkness of the universe. Beneath it all lies a quiet, elegant order, perfect in its balance. And you are part of that order. The matter that forms you carries ancient memories of stars, light, and long-forgotten suns. Relax. Let your eyelids grow heavy. Feel the deep stillness surrounding you. The universe is like a vast, dimly lit room where black holes are oil lamps slowly running out of fuel. When the final flame goes out, the room does not become frightening, only cool, silent and peaceful, ready for an eternal rest. Sleep gently. The universe is calm, and all is well. Our journey tonight comes to rest here. You have traveled through a universe filled with powerful shadows, from millions of small, unseen black holes drifting through the Milky Way to distant giants like M87 star. You have met our own conductor, Sagittarius A star, modest compared to many of its kind, yet the calm and steady heart that keeps our galactic home in balance. Take comfort in knowing that everything has its place and every force has its time. You are part of this grand harmony, a small luminous grain of dust, sheltered by laws older and wiser than memory. The universe is like a vast hourglass. Each black hole is a grain of sand, falling slowly and patiently through the narrow passage of time. And when the final grain descends, it will not signal an ending, but the beginning of the deepest, most peaceful rest. Now, completely relax. Let your eyelids grow heavy. Drift gently into the soft darkness of the Milky Way. Sleep well, and may your dreams be calm and filled with distant starlight. The universe is quiet now, and it is watching over your sleep.